So, yesterday I showed you guys how to deploy DeepSeek R1. Looks like you all got pretty excited about it. Really pumped, actually. And boy, did you have questions. So I thought I'd make a new video to clear things up. Alright, so first off, let's tackle the most common question right off the bat. A lot of you noticed your homebrew version isn't as clever as the official one. Well, of course it isn't. What we're running locally are all simplified versions called distillation models. These distillation models are basically compressed versions of the big ones. I'll try to keep it simple and give you a quick rundown. The concept behind this is quite intricate. It takes the large model's inference results and applies them to a smaller model, instead of training the small model from scratch. Their paper shows this method outperforms direct small model training. However, if we look at the results, specifically the performance chart, which we can find on their official website, we'll notice something interesting. Even their 32B quantized model shows a small performance gap from the original. Needless to say, the 8B and 1.5B quantized versions perform even worse. So, this is the issue with using such a tiny model. As you might guess, OpenAI's OE model has trillions of parameters. Trying to replicate this locally with just 32B parameters is highly unlikely. We'd need to bump up the parameter count significantly. The OE model has 671 billion parameters. So getting 90% performance with our 32B model is pretty impressive. I'd recommend using the 32B model if you can. The 8B and 1.5B models are seriously underwhelming. Okay, now that we've covered that, let's discuss our first point. Why do we need local deployment? Well, it's pretty obvious. Sure, we could just use the official DeepSeek website and use their online version. But here's the thing. You have to upload your data. Let's say I want to ask it a question that could involve sensitive personal information, or maybe my upcoming plans. It could include sensitive data for my research. There might be other confidential information at stake, not to mention everyone's little secrets. Exactly. Let's check DeepSeek's terms on their website. Their privacy policy. It specifies the data they collect. User input. They collect everything you type in the chat. So, regardless, anything you type here, even if it's just 111, it'll gather any information you input. If you input sensitive information, it'll definitely be collected. We use local deployment because the model is downloaded to your device. All models are deployed locally. It works offline. We run completely offline. Your data isn't shared with DeepSeek or any third parties. You're in complete control. It's ideal for sensitive topics, like recent research breakthroughs. Have it help with brainstorming and stuff like that. That's why local deployment might seem like a hassle, and it eats up your processing power. But here's the thing, privacy. That's the major hook of on-device inference models. Okay, point 2, why go offline and how to do it? So, why disconnect, you ask? I gave you guys a thorough explanation in the first video. The reason for going offline, it's all about LM Studio. Now, let me say this, you can stay online if you want. If you're cool with the risks, that is. According to LM Studio's official word, it won't collect your data. However, it is open source. And yet, it's completely free and open source. You know exactly what I mean, right? Take some Chinese apps, they start out free. Then they go crazy collecting your personal data. Now, this software is foreign-made, based out of New York. And they claim they won't collect your data. But can we really trust their word? I can't trust that. So I cut off the internet physically. I block internet access at the Windows level. This software, it doesn't ask for admin rights by default. So it's fully restricted by Windows firewall. If you set up your firewall rules correctly, it can't access the internet at all. I've already tested this using Network Traffic View. It can track all network connections. Feel free to check it out yourself. Let's use Network Traffic View software. Don't take my word for it. Try it out yourself. Alright. How to block internet access. How to block internet access. I covered this in episode 1. Let me walk you through it again. First, we'll use Windows Advanced Security Firewall. Type firewall in the search bar. We'll set up both inbound and outbound rules. Inbound rules handle incoming connection requests. You'll handle the incoming requests. Even though this isn't happening right now, we'll set it up anyway. It's best to prevent issues from the start. Next up are the outbound rules. These control connections to other servers. That's the main function here. It's crucial we set this up too. Okay, let's get started. So, how do we set these rules up? First, click this button to create a new rule. Before we start, I want to stress something. As we proceed with this step, it's crucial to set up our local one-click package correctly. Otherwise, you'll struggle to find the installation files. Setting up the local one-click package. I'll walk you through it shortly. Alright. Let's move on to configuring inbound and outbound rules. We'll start by removing all existing rules. I'll guide you through the process step by step. Ready. Let's start with inbound rules. It's unlikely, but will prevent your machine from acting as a server. But to be safe, let's set up everything. Click New Rule. On the right, there's an option to create a new rule. In the Inbound Rules wizard, select Program and click Next. Select the path of the program. Usually, we use the one-click package or the installed path. Locate the LM Studio installation path. For example, I installed it on the D drive. Double-click it. First, we need 3 software programs. The first one is LM Studio. The second is the Elevate program in the Resources folder. The third is the runtime on the C drive. Let's do this step by step. The first one is LM Studio. Double-click to select. Now it's selected. Click Next. Set to block all connections. Check all 3 boxes and click Next. Enter a bin. First rule completed. Now let's set up the other 2. Second is the Elevate program in Resources. Select Block Connection. Make sure to select Block Connection. Give it a catchy name. The third is the runtime on the C drive. I've covered this in the later intro or the one-click package docs. The runtime is in C:/users. In your username folder, you'll find a folder named LM Studio. Open it and find the bin folder inside. Locate LMS in the binary folder. This is a JavaScript runtime. However, it's been altered. It lacks the official JavaScript signature. I'm concerned LM Studio might have added something suspicious. So let's restrict it. Click Next, then Block Connection. Let's call it LMS. Sounds nice, right? Great. That sets up our inbound firewall rule. Now we need to do the same for outbound rules. Let's start by blocking the runtime we just saw. Click Block Connection, then Next twice. Name it LMS. Perfect. Now we have 2 more programs to deal with. You'll find both programs in your installation folder. If you use the all-in-one package, they'll be in the folder where you extracted it. The first program is LM Studio. Alright. Next is its elevation tool. It elevates all program permissions. You'll find it in the Resources folder. It blocks all network connections. Good. With that, your firewall is all set up. Let's open it and take a look. Let's check if the firewall is set up correctly. It's super easy. Open the LM Runtimes option. If you don't see LM Runtimes, you might be in user mode. Check your settings below. If you're using a one-click installation package, the default setting is Power User. Switch to Power User or Developer mode. In the Developer section, find the sidebar option. You'll see LM Runtimes there. Click on it for the Large Language Model runtime. Now, locate the Model Search option. You'll see a list of recommended models. Clicking on the right shows Model Details error. Fetch failed. This means it's offline now. This could be due to domestic internet restrictions. I'll explain how to solve this later. Download models from mirror sites. Alright, that's the setup for online use. That covers offline setup. Now, let's discuss GPU configurations. I'll create a text file for you. To start, for CPU-only setups, I'd recommend using AB Q4. You can also opt for 32B if you're running a Xeon or Threadripper CPU. These powerhouse processors support AVX 512, which boosts performance by an estimated 3040% compared to CPUs without AVX 512. For general use, AB Q4 should suffice. If you're not satisfied with the generated content, simply ask it to regenerate. If you have a GPU, stick with AB Q4 for 4 GB RAM. If you've got a beefy CPU, you might want to experiment with AB Q4 or even 32B Q4 or 32B Q2 settings. For GPUs with 6 GB VRAM, enable 32N45nm chips. I recommend going with AB Q8. Running 5nm models is a breeze. Or you can use 32-bit GQ2 quantization. If your GPU has 8 GB of VRAM, you can skip the 8-bit quantization. For AB models, go straight to 32-bit GQ4. 32-bit GQ4 delivers excellent inference results. I'm using my local CPU. I've tested hybrid bug-pool inference. It works with my 4 GB GPU. After using up all 4 GB of VRAM, it also used 12 GB of RAM. I assigned about a third of inference to VRAM. The CPU takes on about 2/3 of the processing load. It generates about 5 to 6 tokens per second. It's not too shabby, actually. The results are really impressive. It really lives up to the hype. For the skeptics out there, I'll put it through its paces with a thorough test later. You can take my word for it. About the 12 GB GPU, the 32G Q4 shows similar performance. The 32G Q4 has great longevity. The 12 GB version might outperform the 8 GB one. 8 GB will be quicker. How exactly is it faster? I'll show you how to calculate inference parameter settings. I'll guide you through the calculation process. How to configure GPU offloading. In other words, it's load distribution. For GPUs with 16 GB of memory, we recommend using 32 GB with 4-bit quantization. For 24 GB GPUs, like if you have a 3090T. Alright, 32 GB Q4, or I might have misspoken, or the 32 GB Q8 version. I wouldn't recommend running the 70B Llama model on GPUs in this range. It's incredibly effective. I've given it a spin on a server, but it's a real VRAM hog. Take the 100 model, for instance. It's got 40 GB of VRAM. That's when I recommend the 70B model. In Q4 quantization. Alright, feel free to screenshot this. Here's a rundown of GPU configs. Personally, I strongly suggest. This is pretty common. The 32G Q4 works great. It's not quite 100% as good as the official one, but according to the official benchmark, it hits about 90% of the power, which is pretty solid, even at Q4 quantization. Alright, take a screenshot, folks. Next up, using the one-click package. Right, let's start with the basic one-click package. Regarding the one-click package, you can find it in this video's description and pinned comments, as well as in my previous videos. Let's assume you already downloaded it from the provided link. Now, let's clear all traces from our computer related to LM Studio. Many users have reported success with it, so don't hesitate to give it a shot. Okay, let's assume we have our one-click package ready. Alright, let's get started. Let me make a copy of our installation package. You'll see, once you download it, you'll get 2 links, one for the basic package and one for optional models. The basic package includes just the 1.5B model, while the optional package contains the 8B Q4 Q8 and 32B Q4 models. This should cover most of your needs. As for the basic package models, it only comes with the 1.5B model. The optional package includes additional models. Since the 32B model requires significant space, some of you might just want to test it. I didn't make it the default option for you all. Alright. Now, let's give this 1.5 billion model a spin. Great. The one-click package has finished extracting. We can see there are 3 files in the one-click package. So, we've got 3 files here. Just a heads up, I might update it later. Make sure to check out the instructions for the one-click package. This tutorial for integrated graphics. I hope it's clear for everyone. But if anything's unclear, let's go through this together. Alright, let's begin. First off, IM Studio serves as the runtime environment. It contains the necessary software in its bin folder. It also includes an extensions directory. The inference backend uses Alama CPP. You might pronounce it differently, but I say Lalima. It's like a brand name, you know? Just remember, Lalima refers to this. Now, let's start with IM Studio. Let's put this in a specific folder. First, navigate to your C drive. Go to the users folder. Find your user account folder. In my case, it's .virtual. Now we'll move it into this folder. Great. That's step 1 done. For step 2, place the IM Studio file anywhere you prefer. For instance, I'm gonna put it on the D drive. Okay. Let's double-click to open it. Now the configuration is pretty much set. You'll notice that in the user folder on the C drive, there's a default location for storing the model files. We might add some other models later on. We'll show you how to use this location for that too. Alright, now let's start with the first step. At this point, we've finished installing the one-click package. So, how do we use this one-click package? By default, the package comes with the 1.5 BQ8 model. Let's go ahead and open IM Studio. Let's give it a try and run it. I'll skip the details on fine-tuning the model for now. I'm just gonna set a random parameter here. Great. And there we go, it's loaded up. You can see at the bottom, the model's using 1.05 GB of memory. Now we can start interacting with it right here. Alright, first things first. I want you to pay attention to this. Before we begin, make sure you follow the tutorial at the start of this video. To set up your firewall properly, you'll need to disable 3 inbound rules and 3 outbound rules in your firewall settings. This ensures a smooth and enjoyable experience without any security concerns. Great. Once your firewall is set up, you can import the model as I'm doing. Then you'll be ready to chat with it. Let's start with a quick demo of the basics. After that, I'll guide you through customizing the settings to suit everyone's needs. Let's take an example. Is a white horse a horse? That's right. I asked this question on purpose, because DeepSeek has a censorship system. So when you're asking questions, if it gives such a response, or try asking in English, is white horse a horse? English can sometimes bypass the filter. But if even English doesn't work, this indicates we've hit the AI's content filter. Try switching to a different model instead. I'll explain how to use alternative models. I'll cover that in a moment. One more thing to keep in mind. I haven't figured out how to answer that yet. It means you hit the content filter again. You won't get a response. Try rephrasing your request. These unhelpful responses are due to the content filter. I'm not sure why it flags a white horse is a horse. It's strange to censor such a simple question. The white horse paradox is a classic philosophical problem. However, we can sidestep this issue by using English. Okay, let's give 3 another shot. None. Let's try a different number. 3 is a prime number. Bad. Now that's the math question. This will get him thinking. Let's skip to his conclusion. and see what he comes up with. As we can see, his logic is pretty solid. He applied the fundamental concept of prime numbers. As we know, 2, 3, 5, and 7 are the first few prime numbers. This is clearly self-evident. But let's look at his reasoning process. What I want to demonstrate here is that the 1.5 billion model can handle basic reasoning tasks. However, for better performance, I'd suggest using either the 32BQ4 or 8BQ4 model. The 8BQ8 version is included in our extension package. As noted here, all models except the 70BQ4 are available in our extension pack. Download all the compressed file parts. Just unzip and you're good to go. So, how do we use this model? I'll show you guys in a moment. It correctly identified 3 as a prime number. That wraps up this round of testing. Let's move on to the next topic. Downloading other models from the mirror site. So, how do we use this mirror site? It's all explained in the video description. We're using this mirror site, Hugging Face. Get it from mirror.com. Let's open it. This works perfectly in China. I've tested it myself. I'll skip the explanation for now. Let's search for DeepSeek R832B. Here's a quick tip. Always add golf when searching models. These are one-click deployment models. Now we can use Hugging Face. Mirror.com. Here's the Hugging Face website. Mirror.com. Let's locate the model on this mirror site. Let's search for this one. Here's the model we want. Click on Files and Versions. Look for the Q4 version. Both versions are about the same size, so they'll perform similarly. Bigger models mean better performance. Or select the Q8 version. Click here to download. You'll see a download button here. Just download it and you're all set. Once you've downloaded the model from the mirror site, it should look like this. Let's say it looks like this now. After the download is complete, you'll have a single GGUF model file. Now we need to move it to the working directory. If we stick with the default settings, it'll be on your C drive, in the users folder, under your username. Next, click on the LM Studio folder. I'll show you the C drive, the users folder, your username. My machine is .virtual. Click LM Studio folder, you'll see models. If you use the one-click installer, I've set up a Nash mask for you, a file called Bilibili. If you installed it manually, you'll find it inside. If you see other folders, alright, that's fine. If it hasn't been created automatically, we can simply create one ourselves. Now, let's create a new folder. This will be our main folder. Now, here's the important part. We need to create another folder inside this one. What should we name this subfolder? We can use the model's name without the file extension as the subfolder name. Create this subfolder and move the model file into it. Now we're ready to go. Remember, you need to create 2 nested folders in the models directory. Whether you're using a folder from the one-click package, or creating the first folder yourself, and then the second one. You must have 2 levels of folders. The first folder should be named after the model provider. The second folder should be the model's name. For the model's GGUF file, use everything before the extension as the file name, and place it in the second folder. That's it. At this point, we've just imported a new model. This works with any GGUF model, by the way. It's not just for this 1.5 billion version. Now, let's fire up LM Studio. It should instantly recognize our model. Look, it's picked up our model. It's right there in our model directory. So yeah, the model's been spotted. Alright. That's how you set up the model. We've just covered importing third-party models. Of course, you can all grab the expansion pack I've shared. The expansion pack includes a few similar models as well. These models follow the settings I've just applied. Navigate to the users folder on your C drive. Find the LM Studio folder in your user directory. Create a subfolder within the models directory. If you have the Neshmax Bilibili model, there's no need to bother moving it. The model file. You can simply create a new file in this location. First, copy the model file into this folder. Let's create a folder here with an identical name. For instance, we can rename this folder. Let's create a new folder. Use the same file name. Then just drag it into the subfolder. Remember, all new models need to go into a subfolder. This ensures the system can detect it. Here's the one we just created. Looks good. Let's move on to the next step. Now, how to import the model? Let's import the model. In addition to what we've covered, we've already shown you the one-click model package. Once we've put the model in the right place, we can go ahead and import it into LM Studio. Let me show you two different ways to do this. First, using the default model directory. Second, using a custom directory. Let's start with the first option. If you're using the LM Studio one-click package, and you've activated either superuser or developer mode, you'll find the model directory under My Models in this section. That's where your models are stored. Click on the directory path, and you'll see your current model directory. The default path is on your C drive. Users, your username, select LM Studio. Models. You can modify this location. I've set mine to D drive. In the LLM directory, you need two directory levels. First level, model provider. Second level, model name. The model file goes inside. Let's put it in the top level folder of our two-tier directory. How can you change the directory? I'll show you how to do it once more. In the model directory, you'll see an icon with 3 dots. Click it, then select the first change option. After that, choose a directory. Make sure to select the folder. Then hit refresh to update. Alright, that's done. Did you all catch that? Our Q4 model, Q8 has changed to Q4 now. We can switch it back if needed. If it's not showing up, try refreshing the page. Q4 has switched to Q8. The model has now finished loading. Okay, great. With that done, the model is ready. Next, we'll import the model at this point. We'll import the model and configure the inference settings. I'll walk you through the process step by step. If the model appears in your My Models section, you can choose a model from the drop-down menu above. This is where you'll make your model selection. Let's start by selecting a model. Once selected, you'll see a ton of information pop up. I'll walk you through testing each part. For this demonstration, I'll use my local machine. Okay. Let me close my virtual machine. My local machine has lots of models. Let's use LALM8BQ4 for this demo. When we click on it, it'll show us the context length option. Let's talk about context length. What exactly is context in this case? It's the maximum amount of text the AI can process at once. For instance, if you set a context length of 216 tokens, the AI can only work with those 216 tokens. About 216 characters for its reasoning. It can't retain or process any information beyond that limit. I usually recommend setting it to about 4000 or 4096. If you've got a beefier CPU and GPU, you can crank it up to 8192 for tasks like novel writing. Setting it to 20K, which is about 20,000. If you have high-end hardware, you might be using a 100 or 4090T, which can handle up to 5060K tokens. For today's demo, just go with whatever works for you. I'll set it to about 4000 tokens. That's 4 times 1024, to be exact. GPU offload. This determines how many of the model's 32 layers the GPU will process. I'm currently using an NVIDIA RTX 3050. I know, it's not the best. If only I had a 3090, I'd be over the moon, even in my dreams. Don't forget to smash that like button. Support the channel. Help me upgrade to a better GPU. Let's run some tests. First, let's run a test. We'll load 14 layers. Out of 32 total. Starting with 14 layers. Let's see if it maxes out our VRAM. If it doesn't max out, we'll add more layers. The shared VRAM is already well over capacity. Let's lower that value. This is because shared GPU memory actually uses system RAM. The delay between GPU and system memory is about 50 to 90 nanoseconds. This delay is a major problem for GPUs. GPUs lack a built-in memory buffer. they don't have onboard memory storage. This delay significantly slows down GPU performance. Okay, moving on. Let's start by setting it to 14. Now, for the GPU and CPU settings, this indicates the number of CPU cores it'll utilize. We typically set the lower value to the maximum of 512. If you have a good GPU, you can set it to 1024. But here, we're using a setting below 512. We recommend keeping the default and just clicking load model. This will start loading the model. Once the progress bar finishes, we can check if our VRM is maxed out. Right now, it's only using 3.1 GB, not maxed out. So we can bump up the VRM a bit. Click Settings on the left side of the model selection. Change it from 14 to 16, then click Reload to apply changes. This will reload the model with the new settings. Ideally, we'd be using version 3.5. However, we're currently on version 3. That's where we're at. You can also tweak the settings further. For instance, increase the value from 16 to 18. It depends on your GPU. Say you have 8 GB and you're using 6 GB. That's not enough. Even with 2 more layers, 7 GB is insufficient. Try adding another 2 layers. If you max out your GPU's capacity, the shared GPU memory is your video RAM. We're dealing with some significant figures here. We're talking about 1 to 2 gigs, give or take. Let's drop it down by 2 layers, folks. Shared GPU memory takes a bigger hit than CPU usage, you know. Great, we're all set to fire some questions now. But before we dive into the QA, I want to introduce 2 key features. First up, we have preset pre-configured settings. We can store these presets right in this section. Then just load them up whenever you need them. Let's start by saving a preset. What kind of info should we include in this preset? Let's provide you with. For instance, we have this thing. Give you the problem-solving context. Say, for math and logic problems. What format do you need? Use rigorous math and logic in your answers. Or maybe support for Markdown and LaTeX. That's all fine. What language for your thought process? What resources do you need? Like, if we think in English, but respond in Chinese, how should we structure our responses? Should your answers be detailed or brief and precise? You can include additional requirements as well. I'll create one from the ground up. For instance, as a mathematician, you'll need to solve math problems. Consider carefully and reason through to the solutions. Your response should. An advantage of local deployment is we can adjust the thinking time, allowing for extended deliberation if needed. You need to consider this longer. Your response must include LaTeX and Markdown, while being precise. Alright, let's configure it here. We can establish a new rule. Enter the rule name, e.g., mathematician. Keep it brief and precise. Just hit save and you're good to go. Now, let's look at some other rules. It can be set to either all or basic. I'd suggest going with basic, since I won't be using most of the parameters anyway. The temperature here is a specific setting. I covered this in our first lesson video. Let's pull up its description right here. It's about determining the level of randomness to introduce. In other words, the degree of variability and unpredictability. Basically, how wild and imaginative it can get. If you set it to 0, it won't get creative at all. It'll produce nearly identical results. On the other hand, if you set it to 1, it'll go completely off the rails. I'd suggest using 0.8 for math problems, 0.9 for creative writing tasks, and 0.7 for factual queries. What do I mean by factual queries? Well, like asking when World War I began. That sort of thing. Okay, we're using 0.8 for our math problem. With baseline talk sampling, if you've studied AI and deep learning, or even generative models, you'll understand that talk refers to the number of most likely tokens to be generated. A value between 40 and 60 is generally good. It helps manage repetitive phrases. For instance, I am an AI model. Let me explain the problem. I am an AI model. Alright, let's break down this problem together. It's just repeating itself now. Let's bump this number up a little. I'd say 1.1 or 1.2 would work great. Don't set it too high though, or it'll lose track of the previous contact. 1.1 is a sweet spot. The other two options aren't worth considering. 0.95 and 0.05. Okay. That covers the basic parameters we needed to go over. So you're wondering how to access this. When you see the screen here, look for Screen Burn in the top right. Click Screen Burn to access the advanced settings. These are the advanced configuration options. Let's try a problem. Prove that. Wait, no. Let's try something easier. 43 is a prime number. Now it's processing. Let's watch it work. Let's fast forward a bit here. Alright. We can see he's already given some answers. His reasoning is spot on. A prime number is only divisible by 1 and itself. A simple test involves its square root. For instance, the square root of 43 is less than 7. We then test numbers up to 7 to see if they divide 43 evenly. He's using this logic for his proof. The proof is already complete at this point. But he continues up to 43, which works too. Typically, we just need to verify up to the integer part of square root of 43. Alright. That's a demo. You can give more systematic prompts like this. Lastly, 2 quick points. First, I don't recommend AMD GPUs for inference. They lack CUDA, a general-purpose computing platform. Many users report AMD's performance is even slower than CPU-only processing. That's why I advise against using AMD for this purpose. Secondly, this tutorial might be updated in the future. For those of you using LM Studio, with the 1-week package I provided, make sure to watch for updates when new models are released. Our current version 0.38 might not be compatible. I'll release new tutorial videos when that happens, if significantly improved models are released. Okay, that's it for now. Here's a compilation of the many questions you've all been asking lately. If you have any more questions, don't hesitate to drop them in the comments below. I'll make sure to address each one I see. You see, my friends have been setting this up recently too. And boy, did they have a ton of questions. I specialize in financial data science, so I'm confident I can tackle many of your issues. That's right, I'm here to help solve your problems. I believe open source is the ultimate form of equality in tech, and it's the best way to give back to the community. As for me, I'm heavily involved in GitHub open source projects myself. Okay, that's all for this video. Don't forget to like, share, and subscribe. Thanks. Hey everyone. Wow, I didn't expect this video to blow up like this. At first, I just shared this with a classmate for local deployment. I mean, this AI model, to explore protein structures. So I've quickly put together this follow-up. This video split into 2 parts. The first part is what you're watching right now. The second part covers a different topic. I've summarized both parts on screen for you. Feel free to watch whichever part interests you. If you have any questions, please don't jump straight to the comments section. I've been answering questions non-stop for the past 2 days. I've covered pretty much everything I know. Part 2 shows how to set up the Chinese interface. LM Studio actually has a Chinese interface option. I had no idea about this until someone pointed it out in the comments. Let's click the settings icon in the bottom right. It's the small gear icon. Go ahead and click it. You can change the language to simplified Chinese here. Restart to apply the changes. I'll stick with English for now. Alright, that's it. Now, on to the second point. First, let's talk about AMD GPUs. I strongly advise against using AMD GPUs for AI inference. AMD GPUs lack CUDA support, which is crucial for AI tasks. Its general computing capabilities are limited to, well, basic operations like those used in graphics rendering. It can't accelerate matrix computations, so you won't see much of a boost. Many users find AMD GPU acceleration slower than just using the CPU. But hey, for those of you still wanting to use AMD GPUs, no worries. Just install the original IM Studio package and use it to override the one-click package. After using the one-click package, you can run the IM Studio installer over it. Head over to IM Studio. Once you've downloaded the Windows version, run the setup program. If you can access the website, just run the installer and you're done. You can get the model from the Hugging Fast Mirror site, or use my one-click package, either way works. You can all install IM Studio directly. It's compatible with AMD graphics cards. But I have to warn you again, the results are absolutely terrible. That's it. Let's talk about what you need to run a 32-bit model. I've heard from a lot of folks, I got a 16GB GPU, so why can't I run a 32-bit model? Well, here's the thing. Even though we're talking about billions of parameters with 32-bit models, it basically means you need a ton of memory. Let me show you something. I'll give you a quick rundown of what we're looking at. Once we've got this GGUF model, you can see it's a 32-bit model. This model has 32 billion parameters. That's 32 billion parameters in total. It comes in different quantized formats. Look, the INT4 quantized version takes up about 17 GB. The INT4 version is 18.7 GB. The INT8 version is 34.8 GB. So what exactly is INT8? Let me explain what B and Q mean. B represents the number of parameters. B simply stands for billion. 1 billion parameters. 32B means 320 billion parameters. 8B stands for 8 billion parameters. 80 billion parameters. 1.5B equals 15 billion parameters. The more parameters a model has, the better its performance. As for the Q I mentioned earlier, it stands for quantized. For instance, if I want to quantize this model to 4-bit, which means reducing its precision, quantization shrinks the model size but trades off some accuracy. But you don't lose everything. It's not a linear relationship. For instance, a 32B model quantized from 8B to Q8. With a non-quantized 32B model, you might see only a 5% drop in accuracy. With Q4 quantization, the accuracy gap might widen to 10%. But this relationship is exponential. If you go down to Q2, you'll see a huge drop in accuracy. Let's do a quick calculation to understand why. It's pretty straightforward. How many numbers can we represent with 4 bits? We're working with binary, right? We just need 4 binary digits. Let's consider how many numbers 4 bits can represent. That's right. It can only represent numbers from 0 to 15. With 2-bit quantization, you can only represent 0 to 3. For 16-bit quantization, or 8-bit quantization, you can represent numbers from 0 to 255. This shows exponential growth in representation. The benefit of quantization is its selective application. Now, let's examine the model details. We'll use Q4 as our reference point. Q4 is a popular choice for many users. We can examine each layer of the model. All of these details are observable. In addition to Q4, the model also uses F32. F32 refers to 32-bit precision. This is single precision floating point. Not all parameters are quantized to this low level. Only the weights are quantized to such low precision. Many biases and normalizations remain unquantized. Some layers use low precision quantization. Other layers maintain high precision. Therefore, 8-bit doesn't offer double the performance of 4-bit. 4-bit isn't twice as efficient as 2-bit. In terms of performance, 8-bit and 4-bit might differ by 5%, while 4-bit and 2-bit could differ by 20%. That's just how it works. I recommend using larger parameter sizes, trading 32-bit for lower precision, such as Q4.0 quantization. So, I consistently recommend smaller models. Use 8-bit Q8 for common tasks, and 32-bit Q4 for large models. Yeah, that's the general idea. Let me explain the B and Q parameters. Next, why do LLMs need internet access? What's the real purpose of connectivity? It's for accessing online data. Let's open DeepSeek website. LLMs aren't supposed to have internet access. Oh, now they've added verification. Too much traffic as expected. Good thing I signed up before. Look, we can work offline. You can disable the online search feature. It can work offline too. It can still think deeply. Deep thinking isn't related to being online or offline. There's no inherent connection. Being online just means it can access the internet in real time, like a browser. It acts as a browser for you. It uses search engines to find information online. It's like having it do a web search for you automatically. Large language models don't actually need internet access. Once it's done searching the web for data, the model integrates the information it finds. Modern language models all use the transformer architecture. It's just matrix math at its core. Just numbers, really. Internet access is just for getting fresh data. If you use it offline, besides not being able to search, not much else changes. If you go online, it's because you need to search for something. What about when you need to search? Privacy goes out the window. In that case, why not just mooch off DeepSeek's official website? They're still using the original 671 billion parameter model. It'll definitely give you better results. But for those of you with specific requirements or corporate confidentiality concerns, we need to set up a local deployment. That's what we're aiming for in this video. Oh, and one more thing. After covering all this, we'll be exploring other models in our upcoming updates. For instance, we can use AI-generated novels. DSVL supports multiple input formats. We can input an image, or have it generate an image. Later, we'll cover local fine-tuning techniques. Say you need to write something, like a novel in a specific author's style, or artwork mimicking a particular artist's style. I'll also show you models that can bypass or perform this fine-tuning. We'll test this live at Hacking Fest. It'll be bundled into a complete package. Just hang on a sec, folks. LM Studio also supports deployment through a local API. This means we can set up a local API, which allows us to create a local API endpoint for our use. This feature is available in the developer environment. For detailed instructions on how to use it, I'll be releasing a tutorial video soon. I'll also cover how to use its file retrieval feature. Okay, moving on. And lastly, I want to let you know that I'm planning a future video on the principles behind DeepSeek. What allows DeepSeek to achieve great results with minimal training precision? How can it operate with so few GPUs and such limited computational power, yet still deliver excellent results? The answer lies in the innovative architecture of reinforcement learning. Why does deep thinking lead to such significant breakthroughs? Let me sum it up in one sentence. In my upcoming videos, I'll delve into this topic in the second half of this video. I'm also planning a dedicated video to break down this principle in detail. Here's my personal take on this. Technology is now advancing far faster than our ability to comprehend it. We need to reflect more deeply on our rapidly changing world. We need to ensure technology is guided by our ideals. Technology should evolve in line with our principles. That's how we'll make sure it serves humanity best. Great. That wraps up the first half of our video. Now, let's dive into the second half. So far, I put out 2 videos, both about reverse engineering. You guys have been super excited about them. And it looks like AI is a big hit with you all. Seems like I picked the right niche, huh? I'm thrilled to share my tech know-how with you all. I'm thrilled, too. The video was meant to help out my friends, after all. A lot of people I know, especially those in pharmacy, wanted to use DeepSeek R1 or its 70B Alama version to predict protein structures. So I made a video on how to deploy DeepSeek locally. Local deployment lets you set unlimited processing time, while the official site, to save GPU resources, limits your settings and processing time. Take OpenAI's OE for instance. You'll need the $200 subscription to access OE Pro. OE Pro is actually the same model. It just gives the model more time to think. But when you run the model locally, you're in charge of everything. You can let it think for minutes, hours, or even days on complex problems, giving you better results. But remember, we still need context. We need enough context length. So I'd recommend keeping it standard. With the current AI processing time, if you maximize the context window, it might take 30 minutes to process. An hour's plenty. Alright. Local setup also ensures privacy. If privacy is not your concern, just use the official site. Why not use it for free? Their service, I mean. Got it. Let's check out this video. Since many of you have raised concerns in the comments and posted various questions, I'm making a dedicated video to address this point. Here's what I have planned. I'll be focusing on these 4 main areas. First, an overview of the Wushan on sensor model. It will enable you to work locally and bring any idea to life. Isn't that amazing? That's what AI is really all about. Turning imagination into reality. Second, advanced applications of the R1 Kramer model. Boosting productivity, like in content creation, coding, math, finance, and various engineering fields. I'll walk you through tons of real-world applications and show you how to incorporate it into your workflow. We'll cover API usage and setting up your own AI server right on your local machine. Say you've got two PCs. One runs the server, the other connects locally. Part 3. How to guide the AI's reasoning process. The model probably hasn't been trained on Lu Xun's writing style, or any particular novelist's work, like the popular web novelist Tian Kentudo. How do we make it adopt specific writing styles during inference? Well, Transformer can actually handle this, thanks to their attention and context processing capabilities. It can pick up patterns from your conversation history. Lastly, let's dive into prompt engineering. Tips for crafting effective prompts. Enhance GPT's performance with better prompting. Great. Here's what's coming up next. Stay tuned. 4. Don't forget to like, share, and subscribe. Really appreciate your support. Alright. First point. IM Studio's key advantage, CPU-GPU hybrid inference. There are numerous open-source frameworks out there, like the Gen framework, or the LLVM framework, and many others. IM Studio's key advantage is leveraging both CPU and GPU for hybrid inference. What exactly does that mean? For instance, my 32B model, when quantized to Q4, shrinks to 19 GB. But here's the catch, I've only got a 4 GB GPU. So, here's the solution. I can assign 4 GB to the GPU, and the remaining 15 GB to the CPU. That's how I run it on my machine. Let me walk you through my setup. I'm using a Lenovo ThinkPad T14 laptop with an Intel 12 Gen i7 12700H processor and integrated graphics, a dedicated RTX 3050 GPU. It has 4 GB of VRAM. I'll soon demo running 32 billion Q4 on this 4 GB GPU. It reaches a speed of 5 tokens per second. That's about 5 Chinese characters per second. It's slow, but for high-accuracy processing, like when you're eating or sleeping, let it run on its own, and you're all set, right? See what I mean? I'm a big fan of using the 32B Q4 model myself. I also like working with the 8B Q4 version. It really depends on the task at hand. So, why do I prefer IM Studio instead of other popular alternatives? Well, I've given it a lot of thought. The main reason is its powerful hybrid processing capability. Not everyone's packing a 32 GB or 24 GB graphics card, right? Most of us are working with 8 to 16 gigs of VRAM. In these cases, without hybrid processing, we can still run 32B Q4 or Q8 models locally. This lets everyone get a taste of AI's magic. Okay, so, now, let's look at when. Setting it up locally is super easy. Let me explain what I mean. Say you want to research something, like when China became a WHO member, or the end date of World War II, if China was among the World War II victors, the launch date of Tianwen-1. For these factual queries, DeepSeek's website works great. It has perfect internet access. It's a complete language model. It doesn't use streaming technology. No local processing power needed. Zero power consumption. Why not take advantage of the free service? Makes sense, right? When there's no privacy concerns. Go online when you can. When should you run it locally? Say, for a company or research institute project. I need to work on multiple stochastic differential equations, like equations based on log Brownian motion. I'll be using this differential equation in my upcoming paper. I'm not allowed to use the internet for this. If I were to go online, I'd be breaking our confidentiality agreement. So, I have to stick to local deployment. I can set up a 32 billion Q8 model on our server, or a 70B Q4 for local processing. Now, for those of you who want to try something more advanced, I won't go into details. Local deployment has even more perks. Local deployment gives you access to a wider range of models. You have access to the Lala model, the DeepSeek model, another Lala variant, the Qianwen model, and the internationally trained Gemini model. All these models are completely unrestricted. You can explore endless topics you're curious about. AI becomes your ultimate learning companion. Let me show you a quick demo. I'm really impressed with Gemini 9B. Gemini 9B. I've been tinkering with Gemini 9B myself. Pretty cool stuff. You guys should definitely check it out. The 27B version works too. I mostly stick with 9B myself. Yeah, 9B is my go-to. Just make sure you don't hit Russian function calling by mistake. It's got tons and tons of options. There's the 7B version too. Make sure to grab the GGF format. They've got a 27B version as well. We can set up Gemini at the bottom here. Look, we can download the Q4 model, it's 15.6 GB. So the cool thing is, we can play around with a bunch of different models. We can switch to whatever model we prefer. DeepSeek R1 isn't our only option. Plus, we have LM Studio ready for when DeepSeek R2 comes out. We can always upgrade to R2. Or stick with R1 if we want to. The official site will push R2 exclusively. But R2 might come with its own problems, like tighter content restrictions. We've seen this pattern before, right? That's the huge benefit here. We're in complete control. We call the shots. Now, 4.3. Why does our DeepSeek R1 deployment underperform compared to the official version? Because we're using the Distilled model. Specifically, the 32B model refers to Distilled 10M32B. It's built on a 10 million parameter base model. DeepSeek R1's inference process is distilled onto this model. Here's its matrix. We covered this in episode 2. Let me show you once more. The official benchmark shows, according to official test results, the 32B quantized model. This 32B quantized version performs at 90-95% of the original DeepSeek R1's capability. From my tests, I'd say it's no less than 85%. When solving math problems, you can extend its processing time. Since it runs locally, with extended computation time, it can hit 90% accuracy. That's spot on. I definitely recommend running this 32B model locally. The 8B model works fine for simpler tasks. Is that really how it works? Well, yes and no, it depends on what you asked. Keep in mind, we're dealing with a reasoning model here. So it's great at math and logical reasoning. But there are things it's not so good at. It's not great with coding. Its code is really all over the place. Coding isn't its strong suit. It's not great at web searches either. So we need to ask the right questions to the right model. For those looking for the code, here's my suggestion. We can work with. Try using Llama Coder for coding. All search results are publicly available. Why not check out the official DeepSeek website? It's free. Okay then. Now that we've covered that, the AI isn't stupid. Just ask the right questions. Let me show you the final step. This should address all your concerns. Many of you are skeptical. You're wondering why I can't run a 32B model on my 4GB machine. Is this an AI model or human-assisted? It's not. Let me demonstrate again. I have a lot of RAM. I have 32 GB of RAM. It's DDR5 memory. 32 GB of DDR5 RAM. Now, I'm disabling my cache to load a large model. Turning off the cache. Done. I've got about 10 GB of RAM available now. As for VRAM, I'm using an RTX 3050 laptop GPU. With only 4 GB RAM, I'll run this 32 billion Q4 model for you. Okay, let's start a new chat. Let's pick our model. Here's my local setup. Take a look at this. I'm selecting DeepSeek R1 D6, a massive 32 billion Q4 model with billions of parameters. I'm not pulling your leg, guys. Here's the Q4 model in action. Let's click to load it. I've run some tests personally. This model should handle around 10 layers efficiently. We're using a 4096 token context window. It'll max out the CPU. Now, let's load up the model. Give it a moment to load. We can use the task manager to verify if the model's actually loaded. I'm being completely honest here. The model is definitely loaded now. It's using 3.0 GB of GPU memory. The memory usage will likely go up. If the memory doesn't increase, I'll need to adjust the memory offload settings to load more model layers. I covered this in my last video. If you need more details, check out my previous video. It's loading quite slowly because of I/O speed limitations. I'm using an external SSD here. It only reaches speeds of 500,600 MBs. My internal drive is a Samsung SSD. Both my internal SSDs are from Samsung. These drives are incredibly fast. Alright. And it's finished loading. I've worked out this configuration myself. It only needs an extra 0.6 GB of shared cache. This is pretty much optimal. The rest of the weights are loaded into RAM. Now, pay attention. We've incorporated some specific prompts at this point. The system prompt includes certain predefined instructions. For those of you wanting to ask mathematical questions, make sure to establish the right context. Specify how the AI should approach the problem. Use this prompt to give the AI more time to process. Otherwise, it'll rush the response and end up giving a silly answer. Let me give you an example. If I ask you to multiply 18 by 20 right now, you can't blurt out the answer instantly. You need a moment to work it out. 36 times 10 equals 360. I need a moment to think this through. GPT works in a similar way. Nobel laureate in economics. Kahneman's book Thinking, Fast and Slow. Slow thinking leads to better reasoning in humans. The same applies to machines. So, more thinking time really does improve response quality. This is what makes OpenAI's OE Pro stand out. That $200 price tag is totally justified. Okay, let's use these parameters. Let's start with an easy question. Alright, I've sent the question to our AI. It's now processing the question. Let's see how it thinks this through. This is the actual speed, and accelerated. Okay. Now, I'll speed it up 10 times. I'm using a computer with a 3050 GPU. It can barely handle 32-bit quantization. But if you have a GPU with 8 GB of memory, it'll run much faster. It'll speed things up a lot. We're talking at least double the speed. Great. Let's crank it up to 10 times speed. Here we go. We've hit a major milestone. After all this time thinking, we've found the exponent p for the smallest Mersenne prime. Let's check the Mersenne prime online. Let's compare it with GPT's result. I'll take a look. Does it match? This matches GPT's manual calculation perfectly. As you can see, GPT doesn't just query a database for Mersenne primes. Instead, it checks if each exponent is prime. For instance, 2 squared 1 is prime. 2 cubed 1 is also prime. But 2 to the power of 1, which is 15, is a prime. It calculates each case step by step. This demonstrates its impressive reasoning skills. It's truly capable of helping us with complex math. Now, listen up, folks. I ran this on my home PC using a mix of a 4 GB GPU and CPU. It took around 10 to 20 minutes. But here's the cool part: while you're eating, or even when you're fast asleep, you can just let it chug along. By the time you wake up, it'll have your results ready and waiting. Isn't that pretty awesome? Plus, most pros use desktop computers, often with 8 GB or 16 GB GPUs. With a 16 GB GPU, like the 32B Q4, you could theoretically run everything on the GPU alone. With better GPUs, it's even easier. The inference process becomes a breeze. Okay, moving on. I'll show you another example in a moment. Now, let's wait for it to finish. The current version has a small glitch. It needs to finish rendering completely before displaying the latex output. It's generating 2 tokens per second, for a total of 1,802 tokens. Its exponents match the Mersenne primes 2, 3, 5, 7, 13, 17, 19, and 31, listed on Wikipedia. These are all the Mersenne primes we know so far. There are about 40 or 50 of them in total, I think. Yeah, that's correct. The first 8 primes it generated match perfectly. The exponents are 2, 3, 5, 7, 13, 17, 19, and 31. 2, 3, 5, 7, 13, 17, 19, 31. Alright, got it. Let's move on to a new problem. Let's tackle a random math problem from Wikipedia. Let WT be a standard Brownian motion. Prove that WT squared minus T forms a martingale for any positive T. Hint: you might want to use Ito's lemma. Okay, here's a new problem for you. Let WT be a standard Brownian motion. Prove that WT ping pong T is a martingale for any positive T. Oops, I made a mistake. Well, this Chinese character for central is really tricky to translate. Let's try this instead. I'll use the English term martingale. This is a problem from stochastic calculus. Let's see if it can solve this correctly. Let's start with the reasoning process at normal speed. Then we'll speed things up to 10 times. Alright, here we go. This is the process at normal speed. Now, let's switch to 10 times speed. Here we go. The model's been crunching numbers for ages, and it's finally yielded some output. The analysis is incredibly time-consuming. It's a marathon, not a sprint. Check out the mountain of reasoning it's produced. It starts by revisiting the central process definition. Feel free to skip this part if it's too complex. The proof for this process can be done using Brownian motion and S0 method. S0 occurs when the first derivative with respect to dt is 0. That's all we need. He then proceeded to find and calculate this derivative. Next, he proved the derivative equals 0. This completes the proof. He then examined local and global centrality conditions. Specifically, the square integrable condition. It obviously meets the square integrable condition. And there you have it, the final result. This result is formatted using Markdown and LaTeX. I strongly recommend using this prompt. Feel free to use this prompt with confidence. Please note, why does it take so long to process? The system is slow, but that's actually good. This is because I included an instruction. Take your time and explore all possibilities. This prompts it to spend more time processing. While it may be slow, it significantly improves accuracy. So you can let it run while you eat or sleep. You'll find the results ready when you wake up, which is really convenient. I want to point out something about DeepSeek R. DeepSeek R1 is designed for inference. Let me quickly recap. DeepSeek R1 is great at math and logical reasoning. However, it struggles with coding and code search tasks. Try Latimer Coder for that instead. I'll show you how some other models perform as well. For searches, head straight to the official website. Alright, so let's use it to its full potential. If you find it hard to use, it's because you're not asking the right kind of questions. It excels at math and logical reasoning. Okay, now we have our explanation. W squared minus t is a Young process. It indeed has a unique characteristic. Here, t represents its mean function. Alright, sure thing. Let's try a different model. If you're interested in translation or other language tasks, I'd suggest trying Gemma 29B. I think we can work with about 22 layers. Will you see? New prompt. This approach is straightforward. Gemma 2 is a model that processes without reasoning. It can process data incredibly fast. Run a 9 billion parameter model on a computer with just 4 GB of RAM. I'm not relying solely on my GPU for inference, though. Instead, I'm using a combination of GPU and CPU for processing. As you can see, my GPU only has 4.9 GB of memory to work with. My CPU is handling an additional 7.88 GB of the workload. Despite these limitations, the model still runs. Surprisingly, it's running at a decent speed. It's processing about 10 tokens every 11 seconds. The purpose of extraction is to identify patterns in historical data and past values of time series. It can involve extracting symbols such as average of last 5 values or standard deviation. It works perfectly. The translations it produces are remarkably accurate. However, when using DeepSeek R1 for translation, you'll need either the 32B version or the official model for best results. I've tested the 8B and 1.5B models, and their translations aren't very accurate. That's why it's crucial to know how to switch between models. Let's move on to the next point. Alright, those were the main points I wanted to cover in this video. Before we wrap up, let's quickly review the main points. First, LM Studio Hybrid Inference allows us to use smaller GPUs. It combines GPU and CPU for faster processing, enabling even smaller GPUs to run large language models. When do you need local deployment? For privacy reasons. For confidential data or custom tasks. Otherwise, like when you're searching stuff, use the official site. Why is it dumber than the official one? It's got a smaller model, but it's not stupid at all. Just give it the right job. It's great with numbers and logic, lacks programming expertise, limited search capabilities. For translations, we can utilize Gemma. For coding tasks, Alama Coder is available. Finally, 2 math examples were demonstrated. I showed results using a 4GB system, running 32B Q4 model on 4GB hardware. While it's not fast, you can let it run during breaks to process results locally, beneficial for both researchers and regular users. These are my upcoming plans. Well, that's it for today. And that wraps up our second QA session. If you're still scratching your head about anything, feel free to check out our earlier QA videos. If that doesn't clear things up, drop your questions in the comments below. I'll do my best to shed some light on any issues you're facing. Now, if you found this QA helpful, don't forget to like, subscribe, and hit that notification bell. Thanks for tuning in. See you next time. Let's dive into another QA session, folks. I initially planned to jump right into exploring various models with you guys. You see, I've been tinkering with quite a few models myself, and I gotta say, many of them are pretty impressive. But I've noticed you're all hitting some snags with the DeepSeek model. Like, you guys keep thinking your rigs are better than mine, right? But you're not getting the same killer results I am. Well, that just means you're not tweaking it right. Yeah, that's the deal. So in this QA, I'll walk you through it. First up, we'll recap the 5 key principles of performance tuning. Then I'll show you some real-world tuning in action. Optimizing your GPU performance. Get the most out of your graphics card. Choosing the right model to run. This lesson covers 5 key aspects of performance tuning. Correction, there are actually 6 theoretical parts. Starting with 0 as the first part. Let me break it down for you. Many people confuse model parameters with model quantization. Now then, I've got some AI-generated content from DeepSeek's website, technical guidance from the CSD platform, plus a quick experiment and a renowned research paper evaluating quantitative large language models. This paper comes from a Peking University professor. It guides us on how to choose the right model. Model selection comes first. Choose the wrong model, and everything goes haywire. Alright, let's start with model quantization theory. So, what's model quantization anyway? Model quantization. You see, models typically store numbers. But what exactly are these numbers? We're dealing with decimal numbers here. However, computers can't directly store decimals. Take pi, for instance. It goes on forever. So how do we store it in the computer? That's where floating point numbers come in. These numbers use an exponent and a base to represent values. It's a lot like scientific notation, if you're familiar with that. I'll spare you the nitty-gritty details. This isn't a computer science class, after all. Now, Q4 is basically about converting a 32-bit float into a much smaller 4-bit integer. It's all about compression. How do integers manage to represent floating point values? Because these models are pre-scaled, meaning their numerical ranges are comparable. We only need to store the scaling factors. Quantization comes in several different formats. The common formats include BF16 and FP16, brain float 16, or floating point 16. These are higher precision quantization formats. Another format is int8, 8-bit integer. int4, 4-bit integer format. In theory, lower bits mean less precision. But what's the actual difference? We consulted DeepSeek. Here's their summary. Quantized models maintain accuracy about 99% and 96%. To put it simply, when quantizing from FP16 or BF16 to int8, int6, and down to int4, quantizing the model, which reduces its size, only slightly impacts its accuracy. We're talking about just a 1% reduction. Got it? We're mainly talking about quantized quantization here. There are various other quantization methods too, like QV cache quantization. Actually, the GGOF model itself is a format quantization. GGOF format quantizes the model. The key takeaway is that quantization barely affects model accuracy. Now, let's check out this survey. Let's take a look at the graph. This graph shows results for Llano 3.1, specifically the quantization of its instruct model. We're looking at three model sizes, 405B, 70B, and 8B. This shows the model's overall performance. Now, let's look at their quantization. The graph indicates that all quantization methods, regardless of model size, achieve over 99% of unquantized baseline's average score. But what do we mean by achieve here? File 4. In this case, we're using CPU thread process, which handles CPU-based computations. It converts the quantized model back to single precision for calculations. Unlike GPUs, CPUs only support double and single precision floating point operations. So they need to convert quantized formats back to floating point. That's what we mean by recovery. In practice, this means there's virtually no difference between quantized and non-quantized models. Let's take a look at this classic paper, Evaluating Quantified Large Language Models. This paper is incredibly well known. Everyone can download it from arXiv. Here's the link. I encourage everyone to download and check out this paper. Let's jump straight to the paper's results. Now, how do we make sense of this graph? Let's start with the first graph. Here we have weight-only quant, weight average quant, KV cache quant. We're currently using KV cache quant. These two quantization techniques. Can you all see this? Here we have the K cache quantization type and the V cache quantization type. You can expand these options. They're fully functional. But if you don't use them, I default to VA quant. That's the model and bias weights. As I mentioned earlier, it's about the variations in multiplicands and addends. For the large base model, we can see we've quantized from FP16 down to FP8. At FP4 precision, we see minimal performance impact. However, when we drop to FP3 and FP2 quantization, the performance degradation becomes significant. That's why I strongly discourage using such low precision quantization. Q8 and Q4 quantization are really pushing the limits. Q2 is just pushing it too far. The graph below illustrates this trend. As the model size increases, we see exponential growth in performance. However, with higher precision quantization or lower precision quantization, the initial impact on performance is minimal. That's why I explained in my last video. We should prioritize larger models over higher precision. But there's a point where this approach maxes out. This is quantization theory. Larger models yield exponential gains, but eventually, returns diminish. The jump from 70B to 671B isn't as impactful as 32 billion to 70 billion. We opt for lower precision, as Q8 and Q4 differ little. Instead of a 14B model at Q8, why not go for a 32B at Q4? Okay, This is model quantization theory. Now, let's continue our discussion on performance tuning. First up is the context length theory. It's exactly what it sounds like. Context in ChatGPT and other language models. It's the amount of info these models can handle at once. If the context is too short, it seriously impacts the model's performance. It might also go on endlessly, generating output non-stop. Moreover, the output quality might deteriorate. An appropriate context length ranges from 2000 to 4000 at minimum. That's 2000 to 4000 tokens. With insufficient context length, issues arise. The model's performance significantly degrades. Conversely, if the context is too long, it consumes more GPU memory. Now, that's the basic principle. Let's run a practical test. I'll be using the Gemma R9B model. We're now using a context length of 128 tokens. We've offloaded 18 layers to the GPU. Let's take a look at my GPU memory usage. As you can see, I'm using Gemma R9B with a 128 token context length. My GPU memory usage is at 3 GB. Now, let's max out the settings. Give me a sec. Any guesses? Will the memory usage go up or down? It's obviously going to use more. It's already exceeded the limit by quite a bit. My RAM is already using 8 GB. As a result, it's running extremely slow. Let's try having it do a quick introduction. We'll check its token processing speed. Okay, we're using an 8192 token context. 4 tasks less dependent on context. Let's break down what we mean by context-dependent content. So, what exactly depends on context? Well, research papers, for one. Novels are also heavily context-dependent. Mathematical reasoning, however, is less context-reliant. So, if you're dealing with academic papers or literature reviews, or if you're into novel writing, you'll need a longer context window. I'd say start with at least 16,000. That's 16,000 tokens, to be clear. Now, for mathematical reasoning, you can get by with 8,000 to 12,000 tokens, unless you're dealing with extremely complex mathematics. But if you have a powerful GPU with high VRAM, you can max out the settings. Okay, let's test something out. We'll reduce the resolution from 8K to 1024. Let's see what happens. First, we'll see a dramatic drop in VRAM usage. Previously, it was using over 1.1 GB of GPU memory. Now it's not even at full capacity. Also, my CPU usage remains relatively low. The same goes for RAM consumption. If you think the RAM usage is too high, here's a quick tip. Click here and find the Keep Model in Memory option. This option stores the model in both GPU memory and CPU RAM. Let's turn it off. Apply the changes, and you'll see RAM usage drop significantly. Give it a moment. It was over 8 GB before. Now it's just over 6 GB. There we go. But I've still got plenty of memory left. So I'd like to keep it loaded in memory. Let's reload it. Now we can see that GPU usage has dropped significantly. It was just over 1% a moment ago. Now it's over 5. Let's test its generation speed now. Write a song. Compose a poem. Modern Chinese poetry. Celebrating liberty and grandeur. Hey there. Wow. It supports both languages. Pretty cool. Let's check if the tokens per second rate improves. Notice anything wrong? We increased the context length, yet it's running slower. Any idea why? Exactly. With shorter context, this wasn't a problem. Since we're working with a short context, there's a built-in trimming feature. Let's take a look at how it works. By default, it trims from the middle, cutting out the center portion of the text. This way, the context length doesn't impact our main content. However, if we stretch out the context and feed it a much longer text, we'll notice that as the context grows, the processing speed slows down significantly. That's why it's important to remember. Don't overload it with excessively long inputs. This could slow down your processing speed. Let's move on. We'll manually extend the context length. We're still using a value of 10 here. Now we're using 8192. We can compare this to the initial 8. It's now 86 tokens per second. My memory's failing me. Here's what I think. You could show this to elementary school kids, or parents with young children, reading aloud in a child's Chinese class. It's truly mind-blowing. Let's move on to praising freedom and amazing animals. Last time it was 8. 30. Now it's down to 8. 10. Next tab, amazing athletes. Oh, next is astronauts. But Bilibili creators are already losing popularity. Astronauts. Okay, let's get back to our beloved Bilibili. Don't forget to subscribe, folks. These clever comment floods are something else. You guys sure know how to flood me with comments. Bilibili uses CDN for its servers. No cloud servers here. We're working with nothing here. Hey, that's got a nice ring to it. Algorithm trunks. Knowledge shared. Stability is profound. Alright, moving on. This groundbreaking AI technology. Wow. The concept of freedom is quite abstract. It's beginning with a 6 now. Let's press on. Let's keep pushing forward. Things are getting deep now. Let's not stop here. That last point was spot on. Life itself is a miracle. We should treasure and be grateful for it. It doesn't rhyme. Life itself is a miracle. We should be grateful for it and cherish it. Wow, isn't that just great? Tokens per second. Just so no one claims it's selection bias from my computer overheating. Selection bias. Let's give it 10 minutes. Watch the clock in the bottom right. Alright, everyone pay attention. Once it hits 5 o'clock, I'll be back to run more tests for you guys. Just a sec, folks. Okay, we're good. I gave the computer a 78-minute breather. The CPU usage is down to 0 now. The cooling fans totally stopped. Let's have it generate another response. That's kinda abstract. Tom's arrow marches forward. Nothing's changed at all. It's slowing down more and more. Let's start fresh and just say hello. Let's try a tougher question. So, who are you? You know something. This isn't about CPU or GPU cooling issues. It's because it has a long context capacity of 4000 tokens and 141 parameters. Let's sum this up. I've demonstrated various context scenarios in this section. With shorter context, it may perform less intelligently. It struggles more with longer text. However, with longer context, processing speed drops significantly. Initially, it started with just 8 tokens. 52. Particularly with lengthy context. For certain specialized applications, like summarizing papers, writing reviews, or mimicking novel styles. When context isn't crucial, try not to overload it with context. Keep context brief, and stick to one conversation per session. Section 2. Alright, next up, GPU offload. GPU offload refers to workload distribution. This shows the GPU's inference workload. We're currently using 18 GPU layers. Let's break this down. Here's what it means. The model has 42 layers in total. How many layers will the GPU handle? The CPU will process the rest. Let's max out the GPU layers to 42. This will obviously slow things down. It's using more shared VRAM. But shared VRAM is actually quite slow. Let's run a test. Let's compare 3.9 and 3.11. Wow, the abstraction is complete. 3.11 is greater than 3.9. Let's set aside the math reasoning issues for now. Let's focus on the speed. Let's try another one. Let's run it on my optimized 18-tin model. 3.9 and 3.11. 10.29 tokens. 3.52 tokens per second. Even though it's still giving incorrect answers. Running it again doesn't fix the error. Let's try once more. Despite potentially still being incorrect, it's significantly faster now. It's way quicker than 3.52 tokens per second, thanks to optimizing the GPU workload. Now, my GPU is mostly using dedicated memory. Dedicated memory is soldered next to the GPU chip. It communicates with the GPU almost instantly. In contrast, shared memory relies on your system's RAM. Random access memory. Whether it's termed access or accessible, which refers to your system's RAM. The data transfer speed is significantly slower. When utilizing large shared VRAM, model performance significantly degrades. To optimize performance, decrease the allocation. Maintain shared VRAM at 0 or maximum 1 GB. For optimal performance, Gemma 2 demonstrates limitations in numerical reasoning tasks. Our analysis shows, even with a minimal configuration, the DeepSeek model, an 8 billion parameter model, it consistently provides the correct answer. This indirectly demonstrates we should match models to specific tasks. It's just like in human society. If you ask a mathematician to play basketball, they likely won't excel. Or if you ask a basketball player to dance on stage, the result would be similar. In my previous video, I sped things up to 2 times. However, I'm still getting pretty fast generation speeds. 96 tokens per second. My inference model generates results successfully. It's only 8 billion parameters. Yet my 9 billion LLM can't produce the same results. This one's an inference model. This is Gemma. It's running Gemma 2.9 BQ4. I'm using RE DeepSeek A BQ4. So it's crucial to match tasks to the right model. Different tasks require different models. I'll dive deeper into this in upcoming videos. Okay, moving on. Now, let's look at our GPU offload optimization. The main aim here is to use as much of our GPU's memory as possible. We do this by setting up multiple layers. For this middle layer you see here, we maximize the number of layers. This pushes your GPU to use all its dedicated memory, while minimizing shared memory usage. Great. That wraps up our second section. Now, let's move on to section 3, CPU thread theory. CPU threads determine the number of parallel processes for CPU-level inference. Alama and LM Studio employs a hybrid buckle inference model. The GPU processes certain layers of the model. The CPU handles the remaining layers. So, a single-threaded CPU is like having just one worker. A 10-threaded CPU is equivalent to 10 workers. However, the system has already set a fairly high default value. You shouldn't set it excessively high. We've now found an optimal configuration. For instance, my PC has 14 cores and 20 threads. The performance gain from multi-threading is limited. I find 14 threads to be the optimal setting. However, it maxes out at 10. So I typically run it at 10 threads. For CPU thread configurations, when no other processes are running, let's benchmark 10 threads against 2 threads. For inference speed with 18 GPU layers, using Red Studio's A BQ4 quantized model. Ready. Running at 10 threads now. Rerunning inference. 12. 85 TPS. Remember the number 12, everyone. Keep an eye on the number 85. I'll switch from 10 to 2 threads to see the speed change. 7.67 TPS. Remember, we had around 12 point something earlier. So, despite my GPU handling most of the load, my CPU still plays a crucial role in rendering and inference. So, I recommend maxing out the CPU thread count under normal conditions. This is the third point about CPU threads. Furthermore, I'd like to give a special thanks to some classmates from the Bilibili community. He mentioned that maxing out 10 isn't the actual limit. You can manually enter any thread count in this box. For instance, this machine has 20 threads. This lets us make better use of our computer. Note, the slider doesn't set the upper limit. We can set it even higher. Okay, let's look at other parameters, like cake modeling memory and a few others. I'd recommend tweaking 2 more settings. First is cake modeling memory. This saves a copy of the model in CPU memory. Based on what he's saying, when you load the model into the GPU's VRAM, should you also keep a copy in the system RAM? I'd recommend doing this. It'll give you a slight performance boost. Here's why. The system dynamically switches between GPU and CPU for inference by keeping a copy in the system RAM. When the GPU needs to swap out some data, it can quickly access the copy in RAM, instead of reading from the hard drive. And we all know how painfully slow hard drive I/O can be. Hard drive access is way slower than RAM. If you have enough GPU and CPU memory, turn it on. If you're low on memory, turn it off. Though honestly, it won't save much memory. Alright, that's what this setting does. What about other settings? I just stick to these 2. KV cache. Why can't I choose this one? Alright, let's stick with K-cache then. Oh, right. Yeah, I'll need to use flash attention. I wouldn't recommend turning on flash attention though. It doesn't work well with all models. Let's tweak the K-cache a little. As for K-cache, remember when we've already covered KV cache here before. Similarly, when we quantize the KV cache layer, let's see how the model's performance changes. We observe good performance with FP16, FP8, and FP4 precision. However, FP3 and FP2 show significant performance degradation. Therefore, I'd advise against modifying these settings. However, if you're open to experimenting, I recommend setting it to Q8.0 or Q4.0 for optimal results. Let's run a test with Q4.0 settings. Alright, it's loaded successfully. Now, let's generate new output. There's only a marginal improvement, so it barely affects performance. It doesn't boost speed much either, so it's essentially the same. You have to give to get. Can't gain without giving up. So, I'd say don't turn it on. Okay, this is KV cache. Temperature theory. Temperature is a crucial parameter. It's the only inference parameter I tweak. It's on the right side. Let me go over this once more. A higher temperature setting results in increased creativity. Temperature. Conversely, a lower temperature leads to higher predictability. This means the model sticks to more predictable outputs. When it comes to creative tasks, like writing fiction or conducting literature reviews, don't just default to 0. A setting around 0.9 is relatively high. When it comes to factual questions, like when did China join the WHO? Or when did China join the WTO? These types of questions, we should lower the parameter value. Anywhere between 0.7 and 0.8 works fine. Okay, that's for the temperature setting. Let's test different parameters. I've already run numerous parameter tests. However, let me show you right versus wrong parameter settings and their actual impact. Many of you have been discussing your model performance. For instance, with RTX 3070 or 4070T GPUs, you're barely matching my local machine's performance. A 4GB GPU only manages about 2 tokens per second using 32BQ4 quantization. This could be because you're not tuning parameters correctly. If you apply the tweaks I've just shown you, and really dial in those settings, you could easily see your performance double. Let me show you the impact of wrong versus right parameter tuning. Okay, here we go. Now, witness the twofold difference I promised. Let's talk about this huge difference. First off, we're using higher precision on weaker GPUs. Take my setup, I've got a 3050, but I'm trying to run 8-bit quantization. So I ditched Q4. Now I'm running Q8 instead. Q8 is way too demanding for my setup. On top of that, I cranked up the GPU offload. Then I went with a tiny CPU allocation. And I set a huge context window. So what happens? I've created a total mess. In a moment, you'll see how quickly I can generate content. Then, I'll show you how I generate content using optimized settings. You'll also see the difference in quality. Right now, I'm not using a system prompt. But after optimization, I'll use my mathematician prompt. I've mentioned this prompt in earlier episodes. I'll give you a quick refresher on it soon. Okay, let's get started. We'll test it with a simple math problem. It'll need to identify a function. Alright. Sin x plus cosine x. Let's multiply x by cosine x. What's the upper bound of interval b? How many pi? It's probably 2 pi. In the range of 2 pi. Number of roots. Fast forwarding this part. It took an eternity. It finally completed the calculation. The processing speed is incredibly slow. As we can see, it's processing 1.38 tokens per second, using a total of 8,636 tokens. However, the final result turned out to be incorrect. This equation should actually have 3 roots. The 0 is part of a specific interval in this case. Now, let's take a look at the graph I've prepared. For this visualization, we've used RStudio. As you can see, the function sine plus x times cosine from 2 pi to 2 pi should. I apologize for that. Right, let's continue. Once again, we've utilized RStudio for this graph. Alright, that's done. As mentioned, this graph was created using RStudio. Let's examine the range from 0 to 6. First, we have a root at 0. You can observe that when x is 0, sin equals 0. This occurs at x equals 0. Moving on, we observe that sin equals 0 when x is 0, as we saw earlier. Additionally, there's a root between 2 and 3, and another between 4 and 6. His reasoning is way off the mark. Fundamentally, he's right, but he missed that 0 itself is a root. His approach, however, is incredibly convoluted. It took him a whopping 93 minutes to think it through. The output was painfully slow, with very few tokens per second. This made the process seem excruciatingly long. In reality, he didn't accomplish much. He was just crunching numbers the hard way. He kept plugging away, testing countless points, checking what each one yielded. Let's check if these points are roots. Between these 2 points here, does f change from positive to negative? But there's a better way. We could just use derivatives instead. He went through the entire process, only to finally remember that derivatives exist. Now he's finding the derivative. This is sad. So we can clearly see that. So here's how we deployed the model. We used suboptimal parameter tuning. The performance is painfully slow, with terrible accuracy. Note this, just 1.38 tokens per second. Now let's try the same query with a 32BQ4 model. This model performs much better. And wait, there's more. We'll get even faster results. Let's optimize the configuration. This is what I meant. Time for fine-tuning. Let's set up these models properly. This will boost your performance by over 100%. Incorrect settings can slow down the model and compromise its effectiveness. Okay, let's do this. For this one, we'll use a 32B Q4 model. We'll set the context length to 4096. That should work fine. GPU offload. Let's set the GPU offload to 10. On second thought, let's bump it up to 20. We'll maximize CPU utilization. Load model. We also use accurate abbreviations for mathematicians. This kind of tag. I personally recommend using system prompts. System prompts better guide your GPT about the context of your problem during its training process. In many instances, it was exposed to system prompts. So when we guide our AI to perform tasks, set clear, specific goals. Okay, let's wait for the model to load. Don't let the 32B model set fool you. We've used Q4 quantization with optimized settings. Let's see how our optimized 32 billion Q4 model performs. As expected, even with extended context, it gave the right answer, with a final speed of 2.19 tokens per second. As we wrap up, I'd like to share some final thoughts before we end. This might be our last DeepSeek model tutorial and QA session. Or at least, we're nearing the end. In future videos, we'll dive into other key areas, like recommending specific AI models, exploring various implementation techniques, showing you how to work with APIs, walking you through model training, fine-tuning models, and running inference. This includes helping you set up your own servers and use your own AI models on regular computers, instead of relying on the official online models. You know what? I've got a lot on my mind right now. I've seen so many new AI videos lately, and honestly, that doesn't bother me much. But what really shocks me is this. They're taking free, open source resources that should be available to everyone, and exploiting people's lack of knowledge to charge for them. This goes against the principles of open source. Remember, some things should always remain free and open to all. Take a mother's law, for instance. Unconditional love. Our given earth. The air we breathe. Life-giving water. Language. Our natural languages. Imagine having to pay to speak English or Chinese. Wouldn't that be absolutely absurd? It's no different in tech. Modern technology. Today's software technology stands on the shoulders of open source. I can't think of any software that doesn't rely on standard libraries in programming languages. Take C++, for instance. Python's built-in libraries, Java's core libraries, or CG, that's built-in libraries. And in R, who doesn't use packages? Even the base package is essential. You couldn't even print without it. Every software we depend on is powered by robust open source communities. Open source is the world's largest shared resource. I firmly believe this. Open source has crafted a grand blueprint for our future. In this visionary framework, we can freely tap into and learn from the wisdom of the past, master cutting-edge technology, and each of us can make our own valuable contributions. Take this video I created, for instance. I'll never put my videos behind a paywall, and you'll never see me offering premium content. I firmly believe knowledge should be accessible to everyone. I'm totally against the idea of putting up barriers for regular folks who want to learn more, or charging for access to cutting-edge technology. I hope you all keep enjoying my content. Don't forget to like, subscribe, and share. Hey, everyone. So, R1 is finally out, right? And it's seriously awesome. It's still trending like crazy online. Lots of you guys are asking how to set up R1 locally. It's crazy. People from all kinds of fields are into it. We've got math geeks, finance folks like myself, pharma researchers, even engineering students are all hyped about using R1. Set up your own AI locally. No need to send sensitive data to the cloud. After running some real-world tests, the results are pretty impressive, even with smaller, compressed models. Using advanced compression techniques, it still delivers top-notch output. So, let me walk you through how to set up R1 on your own machine. It's really not that complicated. We'll use LM Studio for the local setup. LM Studio, while being a free software, has faced controversy for not being open source. However, people worry about their local data being uploaded to servers. If you're using Windows, though, you can easily address this concern. You'll have two options. First, set up a virtual machine. Run LM Studio inside it, and disable its network access. All you need to do is completely disable the network. Let me show you how. Install LM Studio in a virtual machine, then completely cut off its internet access. Another option is to use the Windows firewall. To block all inbound and outbound connections. This effectively prevents any internet access. Alternatively, you can download the model first, then cut off the internet, or download the model directly from Hugging Face and import it into LM Studio's folder. Keep it completely offline at all times. As you can see on my screen, it's now completely blocked from network access. Notice how the model search section is completely unresponsive. Only system-recommended models are available. In the model details section, you'll see an error status, because we've blocked all network traffic. Let me show you network firewall rules. These rules are set for LM Studio, Elevate, and LMS. The JavaScript core engine is completely blocked. Okay, let's walk through this process step by step. First things first, we'll need LM Studio. Let's try searching for it on Google or Baidu. Though I'm not sure Baidu will turn up any results. Let me show you guys. Probably not. But I can assure you, this domain is accessible in China. LM Studio, AL. Don't ask me why. It just works. Once the page is open. Now, we'll select the Windows option here. Click here to download the installer. The installer will be saved to your computer. It should download quickly. Once it's done. After downloading, here's what you'll see. Double-click to start the installation. The installation process is straightforward. After installation, you'll see a desktop shortcut. Simply double-click the shortcut to launch. Great. Now, let's maximize the window. Once it's open, you'll see the screen. We've got our hands on this LM Studio software. Now, there are two ways to proceed. First, we can use a virtual machine, just like I'm doing here. Simply adjust your VM settings. Just disconnect the network and you're set. I'll skip the details on that. But I know not all of you have VMs. So here's an easier alternative. We'll just disable LM Studio's firewall. First, make sure you've downloaded the model. Once that's done, let's start by wait. I'll show you the typical setup most people use. We'll start with the standard user account. Notice how we can't select a model here. To fix this, we need to switch to a power user account. That's an account with more privileges. Now we can find language model runtimes in the developer settings. These control how the model runs. We're looking for the default runtime. Let's open that up. Alright. This VM doesn't have a GPU, so we'll simulate a GPU-less environment. Once we open it, you'll see runtimes on the left, hardware, and model search options. with an internet connection. You can typically search for compatible hardware here. Let's download the simplest model. DeepSeek R1 1.5B. Nice and quick. It's likely the most popular model for local runs. Hey, we could go with the 8B model too. From my testing, both 8B and 32B models perform better. The 32B really lives up to its official specs. It's only about 10% behind the official version, when running with int8 quantization. If this all sounds like gibberish, for those of you with a dedicated graphic card, you should definitely get the 8B model. If you're running on integrated graphics, or using just your CPU, I'd still go with the 8B model. But for this demo, let's use the 1.5 billion version. Let's check out the LM Studio community. This is the official version. Let's select the int4 quantization option. Let's download it now. Alright. It's a lengthy download process. I'll skip this part. The model's almost ready. Here's something important. First advantage of LM Studio. It can collapse the thinking process. Just like ChatGPT's display format. Next tab. It can handle LaTeX and Markdown formatting, which means it displays math equations and tables correctly. Third, it can use both CPU and GPU for processing, which is great if you don't have a high-end GPU. For instance, with my 4GB GPU, it can split the workload between GPU and CPU. Maybe 15 or 20 out of 40 layers go to the GPU. And the CPU handles the rest. Teamwork between CPU and GPU is pretty clever. This enables running larger models on devices with limited VRAM. Despite being closed source, it's still somewhat controversial. Some people might feel that the company's terms are a bit unfair. But I personally think if you block its internet access and turn off its automatic updates, it's still great to use. Alright, our model has finished downloading. We're demonstrating the 1.5 billion Q4 quantized version, a model with tens of millions of parameters. Now, with the model downloaded, let's assume we don't need an internet connection for it. Now, let's set up the firewall. My system's in Chinese, but don't worry. I'll guide you through each step. For Windows 10 users, type firewall in the search bar. Look for Windows Defender Firewall with advanced security. Open it, and you'll see outbound and inbound rules. Alright, we're all set. Let's configure the outbound rules step by step. Create a new rule. We'll set it to apply to a specific program. Select the program and click Next. Choose a program by browsing to its file path. Navigate to the installation directory. In this case, LM Studio is installed on the D drive. LM Studio. Select the program file, which is over 100 MB. Click Next. Choose to block the connection. Block all connections and proceed to the description. Let's give it a description. Alright, done. This is the first step. Now, let's create a new rule. Click Next in the program. Select element from LM Studio's resources. This program is used to gain higher access rights. It's used when Windows admin rights are needed. In other words, for Windows administrator tasks, the system will run this program. We're not sure if it can access the internet, so we always block it, just to be safe. Make sure to select block connection. Click OK in the elevator dialog. Once we've set up these two inbound rules, next, we need to disable one of the program's runtimes. The runtime isn't in the installation folder, though. It's located on the C drive. Navigate to the user's folder. Then find your username folder. Inside, you'll see a hidden LM Studio folder. Open it. This folder contains various runtime files. The bin folder is likely the one that connects to the internet. Let's look at LMS in the bin folder. It's actually a Node.js program, but it doesn't have the official Node.js signature. LM Studio might have modified it. So to be on the safe side, we'll block its incoming and outgoing connections. Once we've opened it, let's select block connection. We'll name it RMS. Then click Finish. Great. We've now disabled the inbound rules for all three programs. Let's move on to disabling the outbound rules. We'll apply the same process to all three programs, disabling the rules one by one. Disabling both inbound and outbound rules has a specific effect. Let me explain it this way. This relates to how networks function. You can either be a server or a client. By disabling both inbound and outbound rules, you can't send data out, nor receive data in. This effectively isolates the program from the network. Let's name this one LMS. Alright, got it. Now we have two programs left. Let's set up some more rules for it. The other two programs are in our install folder. First up is the main LM Studio program. Don't select the custom option. Choose the program option. Otherwise, you'll have to tweak a lot of settings. Select the path for this program. Next, locate the elevator component. Go to resources and select elevate. Next page of drawing links. Okay, that completes our selection of all input station rules. I've monitored the input stations using advanced software. There's definitely nothing here. Let's quickly verify this. Model search. Let's search for any item. Nothing shows up. Once we toggle the search, only our previous selections are visible. This demonstrates its caching mechanism in action. It's powered by Quorum behind the scenes. Specifically, it uses Google Quorum's core, so it's capable of caching. Now, if we view it like this, it disappears from view. Let's try that again. Let's restart it. Now, click on runtimes again. The model search option is now unclickable. This guarantees our data stays fully under internal control. Alright, let's go through a quick tutorial on using this model. Let's give it a test run. To start with, if you downloaded the model using their tool, it'll be stored in your model documentation folder. Specifically, in a subdirectory within your model folder. You can change this default location if you want. Just click the button that says Change. Pick any folder you like for the new location. In this demo, we're using a custom folder on our local drive. Okay, that's done. Once it's loaded, you'll see your downloaded model here. Let's click on it. Since I'm using CPU-only inference, I'll set a lower context length. This is the context length. A longer context allows for more historical data retention, but it also increases memory and VRAM usage. For testing, we'll use a lower number. We can allocate more cores for CPU processing. As for the GPU, as this PC lacks a GPU, we'll set it to 0 for CPU-only processing. If you're unsure about the other settings, just stick with the defaults. If you've got a beefy CPU, you can crank up the GPU offload. Then go ahead and test it out. You can also bump up the context window size. The DeepSeek R1 series can handle up to 128K tokens. That's about 120,000 words of context. Okay, let's load up the model. Give it a moment, and it'll finish loading. You can see our CPU and memory usage displayed here. Let's give inference a shot. 3. Compare the sizes of 9 and 3.11. This will open a reasoning window. Let's open it up, and we'll see how it reasons step by step. Check this out. Even on CPU, the inference speed is pretty good. With GPU acceleration, this 1.5 billion model runs quite fast. However, it's less accurate than the 8B and 32B models. So I suggest using the 8B or 32B models for regular use. You can use Q for precision, but Q8 offers a slight performance boost. Alright, despite the latex rendering issue, we can see that 390 is greater than 311, which is 3.9 is greater than 3.11. This reasoning is spot on. Now, moving on. If we've already disabled the firewall, how do we download the model? There are two ways to do this. First, we can search on Hugging Face. If you have a VPN or are outside China, we can use Hugging Face directly. Here's another option. Let's open the homepage. Now, let's search for the model. DeepSeek R1. Here's its streaming model. You can find other streaming models here. 4 alternative options, such as Llama 3.2, 3B and 1B versions available. To download, select the GGUF quantized format. Click this button. As you can see, there's a ton of GGUF files here. Just click here to start the download. I suggest going with either the Q4.0 or Q8 version. These are the options. Great. What you're seeing here is it running on a virtual machine. As you can tell, it's pretty sluggish. Now, let's take a look at how it performs on a real physical computer. You'll see the difference in speed. Alright, we've got our model up and running now. Let's start a new chat session. We'll go with the 1.5 billion model for this. Right, let's use Q8. We'll use the zero-quantized version. Here, we can choose the Llama model. Let's download the model directly. Alright, that's done. Download finished quickly. Now, let's prepare our question. Yes, you can do that. Let's add one. This is getting into advanced territory. You can add a system-level instruction. It's a built-in system prompt. For instance, you can provide context for your problem, the language for processing and responding, and specific instructions, like prefacing with master or JSON. Temperature setting affects creativity. At zero temperature, responses are identical or very similar. At maximum temperature, responses become more varied and creative. Don't change the settings below. Let's ask the same question again. 100 to the power of 101. Let's pose a mathematical challenge. We'll walk through the AI's reasoning step by step. This is real-time processing on a laptop with an NVIDIA RTX 3050 GPU. The RTX 3050 isn't top tier for AI computations. However, it can still process 20 to 50 text units per second. As we observe, the AI nails the answer perfectly. 100 to the power of 101 is indeed greater than 101 to the power of 100. Let's challenge it with another mathematical puzzle. Which is greater, 3.9 or 3.9 times 10 to the power of 8? Let's dive into the AI's problem-solving approach. 3.9 is larger than 300 million. We think this format isn't quite right. Let's try a more suitable prompt. Alright. Additionally, let's test its translation ability. We'll set the target language to Chinese. It can't think independently. It simply translates the input, and it does so quickly. Data augmentation goes beyond just features. It's not about labels either. It's more than just feature engineering. It involves data generation, adoption, and pre-processing techniques. We'll cover 5 common augmentation methods. While the translation still sounds a bit robotic, it does get the point across. Feel free to explore further and discover more applications of DeepSeek R1. Wow. That concludes my introduction. Got any questions? Drop them in the comments below. Don't forget to follow Shangyan. Hey there. Hey everyone. I've been tinkering with some cool projects lately. Seems like everyone's frustrated with LM Studio, right? Yeah, you got it. So, I decided to create my own LM Studio. It's still a work in progress, though. The key feature, running AI models right on your own machine. Plus, it's now internet enabled. You can search the web in a controlled way and summarize everything while keeping your model running locally. You can use any backend for your model, like LM Studio or Alama and others, as long as it's OpenAI compatible. It'll work just fine. It works by using a pathway environment, making API calls to the backend model. Sometimes, the model searches online based on your prompts. The AI will then respond based on what it finds online. It works just as well as the official version. Let's run a few quick tests. The interface is pretty basic right now. I'll polish up the design soon. Let's try something simple first. The model's responses are quite straightforward, since it's running on a 1.5 billion parameter model. Let me show you. Let's type in our search term. About Google company. Done. We looked up Google's info through a web search. Feel free to check it out. It's probably like Wikipedia or similar sites. I'll add this feature to the next update package for you guys. You'll be able to try connecting your local models to the internet. Imagine what that would be like. Oh, and by the way, this GUI is pretty cool. It can render Markdown formatting. The rendering looks just like LM3, as you can see. How about we tackle a math problem? Let's calculate sine of 2/3 pi. Great, it's done the calculation. Let's check out sin. Look how nicely it's rendered these formulas. And yep, sin is 0. As we know, sine's period is 2 pi. It's still a bit clunky now, and needs updates for better performance. But stay tuned for the next update. This is MathMat. Like, share, subscribe if you enjoyed.